Okay, we have to label the opposite, adjacent, and hypotenuse, and this says from the perspective of A. So from A, I'm going to draw my theta, which is what I'm going to use for my angle from A. I need to label those three. First, I label the hypotenuse, which is the longest side of the triangle, and it sits across from the right angle. Then I label the side that is opposite the angle. So if the angle is here, on the opposite side of the angle would be side BC. Leaving the last side, the adjacent side, which is the side beside the angle, but not the hypotenuse. Then I do the same on the second, but this is from the perspective of angle B. So looking from B, my hypotenuse does not change, still the longest side. But the side across from B, opposite B, would be side AC now. And the side beside the angle, the adjacent side, is side BC. Again, opposite, adjacent, hypotenuse. Example, find the ratio of the lengths with respect to angle A. So we are looking from angle A. Let's first label our sides. We have our hypotenuse, longest side. We have the side opposite the angle. And we have the side adjacent to the angle. Now furthermore, we know that this side is 1 and this side is 2. And we would use the Pythagorean theorem to solve for the hypotenuse. So we're going to use a squared plus b squared equals c squared. So 1 plus 4 equals c squared. So 5 is equal to c when it's squared, and when we take the square root, we get that c is equal to the square root of 5. So we fill in our missing side. Now it asks us, opposite side to adjacent side, set up the ratio. So my opposite side is 1, and my adjacent side is 2. So my ratio is 1 to 2. Now I set up my next ratio. My opposite side again is 1 over here, and my hypotenuse is 5. So I set up my ratio 1 to the square root of 5, sorry. My last one is adjacent side to hypotenuse. So I set up my adjacent side, which is 2, to my hypotenuse, which is the square root of 5. Those are my three ratios. Now, let's associate each trig function to its ratio. So the sine of the angle is always going to be equal to the ratio O to H, meaning opposite to hypotenuse. The cosine of the angle is always going to be equal to the ratio A to H, meaning adjacent to hypotenuse. And the tangent of the angle is always going to be equal to the ratio O to A, which is opposite to adjacent. Leaving us this word, so sine is opposite over hypotenuse, cosine is adjacent to hypotenuse, TOA. Tangent is opposite to adjacent. And we can write it like this, so sine opposite to hypotenuse, cosine adjacent to hypotenuse, and tangent opposite to adjacent. SOHCAHTOA. That's the acronym we want to memorize. So sliding down the page, find the sine, cosine, and tangent of angle A. So from angle A, find the sine of angle A. And we know that's equal to the ratio O to H. So let's label. 10 is my hypotenuse, longest side. Opposite the angle is 6. And beside the angle is 8. So I set up this ratio. The opposite side is 6. The hypotenuse is 10. Therefore, that is 6/10. The cosine of the angle, which is A to H, equals 8 to 10, which is going to equal 8/10. And the tangent of the angle is equal to the ratio O to A, which is 6 to 8. Sorry, I'm getting sloppy. Which is 0.75. So that gives me those three ratios. Next up, find the sine, cosine, and tangent of angle A, which is 30 degrees. Well, it should say angle R. Sorry. So we want the sine of 30, the cosine of 30, and the tangent of 30.